So this is the second time that Lisa and I have had an opportunity to speak before a green home group. The first time was, what, a year and a half, 2 years ago, and it was on Zoom, and it was good, but I think there's no substitute for human contact, so I'm glad we're able to do this here in person. Basically, we're going to talk about the same project that we've been involved in, but go into greater detail about some of the nitty-gritty because since the project first was completed, we've just been bombarded with questions about, how much does it cost, how much did you save, what problems did you have, et cetera, et cetera. And so we're going to try to answer as many of those questions as we can this evening, and also talk about what we think might be the future of heat pumps as far as electrification is concerned here in New York and elsewhere. So I think it's going to be an info-packed presentation, and there's going to be a lot of time left at the end for Q&A, so I think most of your questions will get answered by the time we finish this evening. So did you want to say anything, Lisa?
Well, am I starting? Not especially for the introduction, but it is nice to see everyone instead of little boxes with heads across the screen. So it's very nice to have you all here in person. And well, should I just begin or?
Sure. Yeah. No.
All right. So, okay. So I'm just going to give you a little background on the building and what went on in our decision-making process and some of the primary issues that came up in our discussions, which I thought might be interesting to everyone. We're a 10-unit self-managed HDFC co-op on the Upper West Side, and we had a 40-year-old boiler which used oil, burned oil, and we used for heating and hot water. And several people in the building, first of all, some other buildings on our block had recently gotten new boilers and converted to gas. And some of the people in our building they were pushing very hard for us to do the same thing. And I guess I thought, knowing what we do now about the devastating effects of fossil fuel on climate, on our air and our water and life as we know it, no one should be getting a new boiler right now. So I didn't want to lock us into 40 more years of fossil fuel burning. So I began looking into other options. And after first looking into geothermal, which I had heard of before, it was not at all feasible for our building. It was very expensive and very complicated to do in the space we had in the middle of Manhattan. But air source heat pumps looked like a very promising, option. So I was getting bids for heat pumps, while other people in the building were getting bids for new boiler and a gas conversion. And we had many meetings on heat pumps versus boilers. And it went on for quite a long time before we made a decision. And it was a real educational process, because especially back, this was like 3-4 years ago when we started, people didn't know what heat pumps were. And I was also just learning about them. And there was a lot of misinformation out there as well. So it really was interesting to get through the process. And I thought I would go through some of the obstacles and enticements that came up in our discussions.
Can I
Yes?
just do the first couple slides?
Sure.
So this is the building that
Building.
did the deed, and in case there are some of you who aren't familiar with heat pumps or know what they are, what they do, basically a heat pump is nothing more than the window AC that you have in your house or the fridge, except that it can operate in reverse. And what a heat pump does is it takes advantage of the laws of thermodynamics to move heat energy from one place to another. So just as your refrigerator takes heat energy inside the fridge and moves it into the kitchen so that your food can be cool, a heat pump can do the same thing. It can remove heat from the indoors and send it outside, or it can take it from the outside and move it indoors. When Lisa and her building were looking at heat pumps initially, several engineers told them that heat pumps were not acceptable as a heating and cooling setup because when it went below about 40 degrees outside, they had to revert to resistance electric heat, which is much less efficient. And that was true 20 years ago. But a lot of engineers, it turns out, are not kind of up with the times. And for several years now, it has been possible for the equipment to operate in heat pump mode down as low as minus 13 Fahrenheit, which of course is much lower than what we see here in New York. There are basically 4 different kinds of heat pumps. The 2 that you see the most of are what I'll call water to air and air to air. Water to air is a ground source heat pump, often mistakenly referred to as geothermal. Geothermal is what they have in Iceland when the steam comes shooting out of the ground. Ground source heat pump uses the fact that it's a fairly constant temperature, several feet underground, year-round, and uses that as the heat source or the heat sink, depending on the time of the year. As Lisa mentioned, it's a very, very expensive proposition in New York. There are places in New York that have done it at huge cost. Frankly, I don't know why they did it. What we're going to be talking about today are air source heat pumps, ASHPs, which you can see over on the right. Okay.
All right, so in our discussions, I'll start with obstacles. First, cost. Installing a new infrastructure for heat pumps is more expensive than replacing one boiler with another. So it is a higher cost, obviously. Fear of change. Several of the people in our building said, we've had the boiler for 40 years, we know it works, we should stick with what we know. And that is a common attitude. The other one was heat pumps don't work in cold weather, as Tom has just explained. That is not true. But I discovered that a lot of engineers and plumbers who had come through our building and looked, to give us bids and proposals, that a lot of them in New York know a lot about boilers and very little about heat pumps, but that did not stop them from giving you their opinion based on outdated information. So we had to contend with that as well. Let's see. The installation took place in August 2020. So we've now had 3 winters and 2 summers with the heat pumps, and they've worked very well all year round. The other thing that people wanted, which was very reasonable, I thought, was that they wanted to see another building that had done a similar kind of retrofit of a steam heat system to heat pumps, but we could not find one. I asked a lot of people, I talked to agencies, it seemed like no one had done that. So we were the guinea pigs, and now there's a building. We're at that building, and if any of you would like to tour our building, you can talk to Tom or me, and we can arrange that if you would like. So some of the enticements that came up were having control over the temperature in your own living space. So with the boiler, if we were hot, we'd open the window. If we were cold, you put on another layer and you put on your space heater, which we did for decades. But with the heat pumps, we have one of those indoor units that was in the picture. You have a small indoor unit in different areas of the apartment. Each one has its own remote. Each one can be set at a different temperature. It can be on or off, and there are a number of options that you can select for your own preference and comfort level. It's amazing, and it's very radical in New York City to have that kind of control over your heating system. So we all love that. They're quiet. There's no banging steam pipes or hissing radiator valves or noisy air conditioners. And they do heating and cooling, so you don't need the window air conditioners, and we were all really happy to get rid of those. And air quality. The major source of air pollution in New York City is buildings. So if everyone had heat pumps, our air would be a lot cleaner. And also heat pumps are much more energy efficient than boilers. And if we want a livable planet, we need to stop wasting energy and start conserving energy. And Tom is going to talk more about the efficiency in detail.
So, just so that you have a sense of what the original system was like, this is a fairly typical, New York City setup, where you have a single boiler for both space heat and hot water. So the space heating steam goes out this pipe here, and the domestic hot water is made with this system here. One of the interesting aspects of the discussions that they had in the building is that there were a couple folks in the building who insisted that because the boiler was 40 years old, it was near the end of its useful life and was on the verge of collapse and failure, and everybody was going to freeze to death. And that's something, I've heard a million times in my career. The boiler is X number of years old, and therefore at the end of its useful life. I'm over 40 years old, and I would like to think that I'm not quite near the end of my useful life. So, give the boiler a break. But the problem with the boiler, of course, is that it burns fossil fuel and it's killing the planet. So we have to come up with some different kind of approach. So the new system is an air source heat pump system. And in this case, because of what was available at the time, we went with what's called a multi-split system, which includes one outdoor unit. Okay, so these are the outdoor units, ODUs, and then multiple indoor units inside each apartment. Because this project was basically, Lisa mentioned that there were no previous projects that they knew about that they could learn from. And the purpose of this project was to try to fill that gap so that we had real data and real information about how such a thing could work, how such a thing could be done in New York City successfully. So even though the building is only 10 units, our hope was that it would be applicable to buildings that are much larger than 10 units. So one of the many fights that we had when we were designing this thing was some folks wanted to put all the outdoor units on the roof, because that's a fairly easy thing to do. And then, access would be fairly easy in case of maintenance and whatnot. But I was against that because a lot of buildings aren't going to have that option, right? Anything much taller than this building, you couldn't put them on the roof because the refrigerant lines would be too long and so forth. So we wanted to show people that there were different options. So we put 4 of the 10 outdoor units on the roof. And then we put another 4 about 8 or 10 feet off the ground on the east and west sides in the back. And then the final 2 we put off to the side of the fire escape. So they're still accessible for maintenance, but they don't block the fire escape in case of a fire or whatever. So that's at least 3 places where you could put these things instead of just one place. Yes?
How do you service the rear wall units?
How do we service what? These?
Yeah.
You get up on a ladder.
Oh.
Yeah, they're only 8 or 10 feet off the ground.
And you place the units strategically to proximity to the floors, correct?
Can you say that again?
They place the units in proximity to the line.
Oh, to the apartment?
Yes.
Yeah, absolutely. Because there are limitations as to the total run of refrigerant piping that you can have. And in fact, we got closer to that limit than I would have been comfortable with, but yes.
Just to clarify, it's multi-split because there's outdoor and indoor?
No, a mini split is one outdoor unit and one indoor unit. A multi-split is one outdoor unit and more than one indoor unit. Now, in this case, each apartment had one outdoor unit and either 3 or 4 indoor units, depending on how the apartments were sectioned off inside. All the apartments were the same footprint or the mirror image of each other, but the rooms were divided up different ways. Yes?
How big is the building? How high?
I'm sorry?
How high is the building?
How high is the building? It's 5 stories. Yes?
And did you need to cut into the building in order to run the appropriate wires?
That is an excellent question, which Lisa will be talking about in a few minutes.
Okay. That was the big issue.
There's a question back there.
I'm sorry?
Somebody's raising their hand in the back.
Oh, yes.
Oh, just because it seemed like it was question time. Can I ask you a question?
Yeah, of course.
So,
No.
I'm a strong proponent of heat pumps, and so 2 questions. One, probably later we'll get into the different temperature swings from the high-quality ones versus the low-quality ones, which, traditionally give AC. But my question is about the fact that I see so many recently mounted on the facade of a building, the front of a building, and I personally, I know that it's less expensive than putting it on the roof. I know that the city's coming out with this City of Yes. There's a new initiative by the Mayor Adams called City of Yes. And
I may have heard something about it.
it's all, it's encouraging this type of stuff. And so I wonder if there's a way that it can be advocated for to not put these splits in. Like, for example, we don't run our boilers on the front of our buildings, right, guys? Right? We don't do that. We do put air conditioners in our windows. That's a standard. But I just wonder what the thinking is of these things being mounted every random freaking place just to save 20 feet of copper and conduit. It's just a seed I want to plant about the best place to put these aesthetically for our city. Any thoughts?
You don't work for Landmarks by any chance, do
I
you?
know, but not before, but with, and I like them very much.
Well, so this is an issue that I know is going to come up, okay? And when we were doing this project, I knew from the get-go that there was no way they were going to put any of the outdoor units on the facade of the building, okay? I knew that aesthetics was going to rule in that regard, and I turned out to be correct. And I suspect most buildings would be like that. However, most buildings only have 1 or 2 facades, and the rest of the walls are hidden from public view. And actually, if you're able to remain with us for the full length of this presentation, you'll see an alternative that might appeal to you so that you don't have to mount them on the walls in an ugly fashion. But it's a matter of opinion. I mean, my feeling is, aesthetics are important, but I want my grandchildren to live where they live in Brooklyn without having their whole apartment be underwater. So, there's choices like grandchildren, aesthetics. I don't know. I'm not sure which one I would pick, but you see the problem. Okay, so these are the indoor units.
So I guess just about that, what you're saying. For our building, for example, we have most of the units are on the sides of the building and on the roof, so they're not visible on the roof. The sides of the building have an air shaft, which is right in the middle. You can't see it at all from the street, and little alleyways in the back of the building. So they're really not visible very much.
I'm sorry to ask one more question, but what about noise? Because we have noticed a extreme uptick in noise around our building, from people putting these kinds of units around.
Well, what's remarkable about these things is that they're insanely quiet. I was frankly surprised. They're quiet on the inside, they're quiet on the outside.
Yeah, one time we were sitting on the fire escape doing something with them, I don't remember what, and I was amazed too at how quiet it was. And we had, one of my neighbors was down on the bottom and was asking about that, and I was like, Hey, Felix, this is so quiet. Come here and listen. I mean, you really hardly hear them at all. And I have one right outside my bedroom window, and I've never heard it. It's never bothered me. However, the building next door has a big air conditioner in their window, which drives me crazy at night.
Similar.
Yeah.
Yep.
The indoor, is it a centrifugal fan or propeller fan?
The indoor units both use a very similar kind of a fan. It's very long and thin, so it's more like an axial fan. The outdoor units, I don't know if you can see. The outdoor units have a big fan, like this is like almost 2 feet in diameter. It looks like a box fan.
Propeller fan.
Okay, but the indoor units, they're long and thin, and they're extremely quiet. They only use about, in this case, about 28 watts. It's really remarkable.
It's a squirrel cage fan, right?
Not exactly. I mean, like I say, the fan is about this wide, and maybe this diameter, something like that. So these are the two most commonly found indoor units. These, like you've seen these all over the place. They mount up on the wall, and then this is more looks like like a fan coil unit, like you might see in a hydronic system, and this mounts at pretty much floor level. One advantage of these is that it's way easier to clean the filter out because you don't have to get up on a ladder. Oh, yeah. Note what it says on the bottom. These are cold climate heat pumps. There are no backup resistance electric heat elements. Okay? There's no backup system. And we haven't had any problems in 3 winters and 2 summers.
They have a low ambient sensor, that's why.
Say again?
They have a low ambient sensor, that's why.
Well, it's just that the technology is such that these don't operate down to minus 13. I think these operate down to minus 5, something like that. But they're in heat pump mode, way, way lower temperature than you would ever need. Yes?
And even, we had those 2 real cold snaps this winter when my pipes froze twice. You guys didn't have any problems even then?
No, not at all.
No? No? Yes?
Did you maintain the boiler for pent-up?
Well, yeah, because as we'll talk about later, the domestic hot water still comes from the boiler. Yes?
I know you're gonna talk about costs next, but did you have to bring power into every apartment? More power into each apartment, or was there enough?
That is a topic that I'm going to speak on at length very shortly.
I'm sorry, can you repeat the question, because I couldn't even hear?
The question was, did we have to bring extra power to the apartments?
Ah,
And that's a subject that I could bore you with to tears for hours on end, but I'll try not to. Okay, so this is kind of the stuff everybody wants to know about, right? So I'm going to go over this in some detail. So it was kind of a challenging calculation to make because it's difficult when you are burning oil to figure out exactly how much was used for space heat and how much was used for domestic hot water when it both created by the same boiler. What was really interesting about this building is that they were very parsimonious with the heat. And so, unlike most New York City buildings where the average is about 15 BTUs per square foot per heating degree day, these guys were down around 10 BTUs per square foot per heating degree day. There are 2 apartments in this building that have no radiators. I don't know why that is, but there are. And so one of those apartments with no radiators never used a space heater. The other apartment did use space heaters quite a lot. So we had to figure out, all right, how many kWh were they using for space heat? How many gallons of oil were they using for space heat? It was a little tricky, but when we crunched all the numbers and we included all the costs of everything, including some air sealing and some other stuff, we came up with let's see. We came up, first of all, with 67% energy savings. We came up with 64% greenhouse gas reduction. And we came up with 2% energy cost reduction. And the reason that the energy cost reduction was not greater is because electricity is so much more expensive than fossil fuel. However, that was one set of parameters. And in fact, when I first learned that this building was only 10 BTUs per square foot per heating degree day, I thought, what if we don't save enough energy? What if their costs actually go up? You know, this is going to make a hard sell, an impossible sell. But I thought, all right, roll the dice, see what happens. So we actually did save on energy costs. So then I thought, well, okay, so that was one set of circumstances. What if there were other circumstances that were to obtain? Would you still have savings, or would it be a big problem? So when we did the project, they were paying an average of $2.48 a gallon for fuel oil, which would be the equivalent of $1.77 per therm for gas. And you can see the equivalences here. And one of the things that a lot of people say, just like some people say, oh, heat pump below 40 degrees, it goes into resistance mode. Well, see, that's actually not true. Well, same thing, people say, well, maybe you can save money with oil, but you can't save money with gas. But if you look at the fact that they save money spending $2.48 a gallon on oil, and the equivalent gas price would be $1.77. Well, here's a bunch of real-world gas prices per therm from the last couple of years, and they are way higher than that, which means that there are going to be many gas-fired buildings which can also save money. And then the other thing that's fascinating to me is that since 2020, this building has had wild swings in oil price. And so if these prices had obtained during the period where we took the measurements, they would have saved way more money. And I'm going to show you how much in just a second. So if, for example, instead of an average of 28 cents a kilowatt hour, they only paid 26 cents a kilowatt hour, which half the people in the building paid 24 and half paid 28. So if everybody switched over so that the average was more like 26, they would have saved 6% on their savings, boom, like that. If instead of paying $2.48 a gallon for oil, they paid $3.45, their cost savings would have been 20%. If it had been $4.06, 28%, $4.30, 30%. And these are all numbers that they have spent on oil in the last couple of years. In terms of greenhouse gases, which is the most important part of Local Law 97, anybody not know what Local Law 97 is? Okay, Local Law 97 says you have to reduce your greenhouse gases 80% by the year 2050.
And that's for larger multiple.
Buildings 25,000 square feet or over, yes. So when we were doing this calculation, the fuel mix of electricity generation for New York was 0.289 kilograms per kWh. And at that rate, we were saving 64% greenhouse gases. However, during the project, Indian Point got closed down. It got replaced mostly with gas-fired units. And the data has not caught up, so we don't know what the new figure is, but I estimated that it increased by about 33%. So if we say, oh, no more Indian Point, now we're creating more greenhouse gases per kilowatt hour, well, we still save 58%. If, on the other hand, CLCPA, which I can't remember what that stands for, community size, I don't know. It's a state law that says we got to green the grid by 2040 or something like that. So eventually the grid is going to be a lot cleaner than it is now. Let's say instead of increasing 33%, it decreases 33%, now we're up to 71% greenhouse gas savings. That's starting to get us pretty close to 80, right? And then the last I want to point out in here is they started out at 10 BTUs per square foot per heating degree day. If they were still below the average at 12, they would have saved 15% of their costs. And if they were at the average, they would save 28% of their costs. Now, the key assumption that I make here is that everything above 10 is wasted, is the window being opened up and the heat flying out. Now, do I have proof for that assumption? No, I do not. But if you can prove me wrong, I'd be very happy to see that. But I think the vast majority of the difference between this and this is whoosh, going out the window, literally going out the window. So we go from 2% savings of energy costs to a pretty substantial number.
Do you have data on your, like, the electricity bills? I know the summer bills went down because it's more efficient to air condition this way, and your winter bills go up. But do you have your electricity bills?
So this calculation includes the actual kWh used by each heat pump. We set up a instrumentation system so that we could get the individual kWh for each one of the heat pumps. So it's not an estimate, it's the actual usage. And I offline I can show you that if you're interested. Yes?
What happened to the maintenance portion of folks' monthly maintenance, sorry, the utility portion of monthly maintenance? Like, because usually you pay for your heat on the maintenance bill, and now they're paying for it directly through their electricity bill. Do they get a reduction in maintenance?
Mm-hmm. Yeah, that definitely was a change. The heating used to be part of the maintenance. Now people are paying for it individually on our electric bills. We decided at that point not to reduce the maintenance because we still have to get a hot water heater, which we're thinking about. We would like to not use the boiler at all, for hot water, but we are now. So we didn't do that, but that is definitely something buildings could do.
Yeah, so this is the opinion page. I feel very strongly that if we do make a wholesale change over to heat pumps, that the user needs to pay the electric bill. This is a big change for a lot of people. It's an even bigger change in the affordable housing sphere, which I work in on a daily basis. But I believe that feedback mechanism has to be in place if we're actually going to reduce our greenhouse gases 80%. The second area of debate, and right now I'm losing this battle, but I'm hoping eventually to prevail, is that a lot of folks think, all right, well, we're going to get the heat pumps put in, and then we can rip out the boiler and, I don't know, put in a gym or something. I don't know what they're planning to do. I recommend against that because when we hit the critical mass of heat pumps, Con Edison's peak demand days are going to be in the wintertime, not the summer. And they are going to be desperate to have ways of keeping that peak at a controlled level, just as they do now in the summer. Right now, if you're a big user and you agree to go offline certain times of the year, they will pay you to do that. And I believe that Con Ed is going to do exactly the same thing in the wintertime to users who are willing to go offline when it gets really cold out. And so the only way to really do that without freezing is to keep your old heating system and use it, I don't know, 100 hours a year or 50 hours, whatever it is. Yes?
So, did you just work that way? Like, do you just sort of have to be off most of the time, and then suddenly they work again when the problems develop when you don't use it most of the time?
All right, I'm having a hard time hearing you, but I think what you're,
The problems develop if you don't use your heating system, but maybe like, a few weeks in a year. Like, does that work for your boiler?
yeah, it's a good question. And I think the answer is very similar to what people do now with backup generators. They test them, I don't know, once a month for half an hour, that sort of thing, which is very standard. Yes?
So your opinion on that is more related as a financial incentive for the building, or you're broadly concerned about people? And each building has a role to play.
Well, I mean, this ties in with, somebody asked earlier about the increase in the electrical capacity of the building, and this is one of my real bête noirs. My goal is to have as little work done increasing the capacity of the system as is humanly possible, because it's going to be hugely, hugely expensive, and it's going to make electricity prices increase, and there aren't enough electricians in the whole world, I think, to boost the capacity of every large building in New York City. So if you have an existing system and you can use it as a demand limiter, then you're much less likely to have to upgrade the electric, and it just makes the whole process more affordable.
So
Yes?
you didn't have to upgrade the electric? Is that what you're saying?
I'm getting to that, but yes, the short answer is no, we did not.
And how many amps did each apartment have?
Each apartment had what I believe is the minimum that I've seen in New York, which is 2 legs of 40 amps.
So 80?
Yes,
Oh, okay, because we have 40 each.
40.
And we're doing a VRF system because we can't bring power into each apartment.
Yeah, well, have you signed any contracts yet?
We just got the contract today.
Well, don't sign it yet, okay? We can talk later.
22.
Okay, I think, are you gonna talk about this?
You're, about what?
Am I talking
You were
about
going to do testing. You were going to talk about testing.
testing?
Yeah, testing.
What do you mean?
Oh, the installation, aren't we doing that? Installation issues.
Yeah, well, there it is.
Yeah,
So do you want to talk?
you were going to do the testing part first.
I can't remember what you're talking
Oh.
about. Yes?
All right, I can if you want.
Well, but let's answer the question first.
Thanks. It's about the condition of the insulation at start. Is this building like modernly insulated? When you did all those heat calcs, I mean, I couldn't see the numbers, but I assume they were heat calcs. I don't know what R values you were using for walls and ceilings and so forth. So are you assuming that this building is, because it's an old building, but is it, what's the walls and the roof R values? Did you upgrade any windows or insulation separate or on this program?
We did not. Subsequent to the installation, we did insulate the ceiling on the upper floor apartments, but that was actually after the fact. And one of the reasons we did that is because we want to try to keep the cost down. But another reason was that we wanted to try to make this as applicable as possible. And a lot of buildings don't have insulated top floors. So we wanted to see how that came out, yes.
And I think, unlike a single-family home, what you did is more applicable because it's less critical. You got less exterior per unit, so I agree with you on that.
Oh, that's good. I should mention that for this project, and this probably wouldn't apply to most projects, we had an engineering company do a heat loss calculation of each apartment, and they all came out at approximately 36,000 BTUs per hour heat load, which was larger than the cooling load. This is a climate where the cooling load is actually lower than the heating load. So each of the outdoor units is what's called a 3-ton unit. A ton of cooling is 12,000 BTUs per hour. So each apartment has 36,000 BTUs per hour heating and cooling capability.
How many square feet is the apartment?
I'm sorry?
How many square feet is the apartment?
Around 800.
Okay, so we had some crazy stuff happen during this project. A lot of crazy stuff. So I think the craziest thing of all was this, okay? So you see this product code here, and the contractor brought in a whole bunch of these with this product code. And the installers started saying, wait a minute, these don't fit. The outdoor units don't fit on these brackets. And then they were arguing with their management, and the management argued with the supplier, and said, no, this is the right one, this is the right one. Well, it turns out that the original ones that they brought in with this product code did not have the little green stickers on them. And so they were the wrong ones. They finally figured out that the ones with the green stickers were the right ones, and they got that solved. We had specified a condensate pump that would fit inside the indoor units because a lot of people had this aesthetic thing going on. And the contractor decided, without consulting with us, to put these ones in instead. So we went back and forth with them on that. It was a giant pain. But this is the kind of stuff that you're going to run into. And you never know. You never know which thing it is that's going to get screwed up. Yes?
And the condensate pumps push the moisture back out from the units, correct?
Yeah, so when you're in cooling mode in the summer and you're pulling humidity out of the air, that humidity has to go somewhere. When you have a window AC, it gets thrown into the fan on the outside, and it's called a slinger ring, and it goes onto the condensing coil, and it actually slightly improves the efficiency of the system. You can't do that with this. So you have to have a place for the condensate to collect, and then you either have to drain it directly outside, or you have to have a pump to send it somewhere where it can go wherever. And we'll talk a little more about that later. The contractor basically lied when we asked for their bid. They said that they had people on staff who were trained in the installation of this particular equipment. Turned out they weren't. So they did a lot of crazy stuff during the installation. Fortunately, I was on the scene and I was able to kind of pick up some of this stuff, but not every project is going to have that. Lisa and I are still trying to find the time to write a little booklet for all the things you need to worry about. Someday we'll finish it, right? Yeah. But there's a lot of little details you need to know, because there's all these ways you can cut corners. Yeah, this is kind of complicated. You can ask me about it later if you're interested. You want to talk about this?
Oh, I was going to do with the outside leaves, but
Well, you can talk
do
about
that.
all of this. Oh, yeah, let me just, so originally, with respect to the whole thing about condensate, I felt that we could use the existing steam pipes as the condensate conduit, if you will. And in looking back, I shouldn't have backed down on that, but the manufacturer was all uptight that somebody was going to sneak downstairs, turn on the steam boiler, and destroy all of the indoor units. I said, look, I'll put a lock on the steam valve, and I'll have the key, and I live 10 blocks away. They can't do that. They were just too freaked out, so we didn't do that. As a result, we had to put in condensate pumps, and/or we had to drill through the brick wall, which created some problems, which Lisa's going to tell you about in a second. Oh yeah, just one other thing. The contractor, sometimes the fins get bent, and that's not good for heat transfer. And we asked them to straighten them out, but they said they did not have a fin straightening tool. Yeah, they do cost $10, I agree. But my feeling is they should have had one, but they didn't. Okay.
So, we had a lot of surprises with the installation. The one that I found the most remarkable was when they did drill through the walls for all of the refrigerant lines, the electrical lines, and the condensate hoses. I assume that that process would include closing up the holes also, but they instead closed up the holes on the inside walls, but did not feel the need to do so on the outside walls, not for all of them. So the first big rainstorm we had, there were massive leaks in some of the apartments, right, where those lines went out, you know. So after a lot of arguing back and forth, and saying, you cannot leave this way, they finally sent some very unqualified people to fix the holes. And this is an example here. So this is the hole originally. This is the fixed. And that's really true. So in the end, we ended up having to get another company to come in and do the sealing of the outside holes, which we have a picture of also. Oh, where is it? Oh, on the far left side. Oh, your right side, my left side. Here, there we go. Right here. Right. Oh, wait, where's, okay. You have them in funny order, but okay. This is the before.
Here, would you like the
and
pointer,
this is
Lisa?
the after. Here. You don't think I'm tall enough to read?
Well, I mean, I know I'm not tall enough.
Okay. This is what the contractors left us with, and this was it after being sealed up by the other company. And this is this other one I showed you before, where they had the piece of foam hanging off the side. So when you get a contract, make sure that it says sealing up every hole on both sides, inside and outside, completely.
The people you hired to fix the problem, are they like people pointing the brake or different kind of brake?
Well, this company, they do a lot of things. They do masonry, so yes, they do that too.
Because
They're very
like
good.
window cleaner or something.
Well, no, actually, he's a tree guy.
Oh, yeah, this is the guy that the installers sent to fix it, which totally didn't make sense. The other one on the little, what is that called, the thing?
Scaffolding.
Yeah, it's like a movable scaffold. That was the one that actually fixed it.
Yes.
I was wondering, is the industry standard to use line hides for a lot of these kind of things? Because I see walking around the city, it's now almost like Where's Waldo, where we keep spotting, oh, they installed one, oh, God, that looks awful. Aesthetics does matter, and some of it looks like intestines, just kind of,
Yeah, I mean, that's incontrovertible. Line hide is ugly. All right, it's less ugly than the intestines, but it is still ugly.
No, but I'm saying that some people's jobs didn't even include a line hide, so it was all the
Yeah.
all the
Yeah, well, you don't want
Yeah.
to see the outside walls of this building because there's the intestines are everywhere. But you can't see it from the street. You can't see it from the street, okay?
On your building. Your building.
Yes.
Yes.
These go in air shafts?
What would it?
Can they go in air shafts?
Can what go in the units?
Oh, yeah, actually, some of the piping does go in the air shaft. But if it's an air shaft that is only open at the top, you can't use it for outdoor units, because we initially thought of doing that. But there's a lot of places to hide the ugly intestines. Inside the apartments, we either had soffits or line hide. Line hide is ugly, I'm not gonna disagree with anybody, but it is less ugly than just seeing the snakes everywhere. Yes?
Is this a tenement?
I'm sorry?
Is this a tenement?
I'm sorry.
Is it a
A
tenement?
tenement, yeah, it's like old tenement style building, yeah.
Yes?
So I just, like, an observation is the problem was fixed by fixing the masonry, correct?
Yeah.
Right, the guy pointed it, he did a great job patching the wall.
Yeah.
So we learned the hard way that all these lines, every single conduit and refrigerant line, water runs down it. So they have some type of, like, good guys have a way to make like a U like this, so that when the water runs down, it drips. So in other words, you bring it down further than your penetration, you turn it up almost like a trap in plumbing, you go in the wall, and it solves all the, many gallons of water running down the line. So people over there mentioned they're doing a new application. That's something we look for now. In other words, a few extra feet of refrigerant pipe or electrical conduit will keep your building dry. You get my point? It's like you bring it down below the penetration point, loop it up and go in. There's a term for it, maybe someone knows, I don't know, but it would have fixed your picture on the lower right there. See the picture on the lower right? Even though it's patched, you're still gonna have water running down those three white pipes for 20, for the lifetime of it. But you, in other words, if you know what I mean?
Yeah, I mean, again, I think this is a matter of opinion, but if the water runs down that white insulation and it doesn't go inside the building, I don't really care, because when it rains out, the building gets completely covered in water all the time.
Yeah, no,
The problem with the solution that you mentioned is the fewer bends that you have in the refrigerant pipe, the better, in my opinion, even if the length extra isn't that much. But again, I don't want to get bogged down on that just now, but yeah. If you wait till the end, we're going to show you how you can get rid of all of this stuff in one fell swoop, but you got to be patient. Was there anything else?
I think we should go on.
I have a quick question. Is there a limitation, like distance, between the multi-family units to the apartments?
Okay, so we had lots of other crazy stuff happen. Sometimes they didn't insulate the pipe all the way. And that can actually be a big problem, because if moisture gets between the pipe surface and the insulation surface, sometimes that can create corrosion that can create pinhole leaks. So that's something you have to watch out for. And then the picture on the right, I mean, I don't really know how to explain this, how someone could have left it like that. But that's the main disconnect for one of the outdoor units, and it's, if it rains or snows, I don't know. I was always taught electricity and water didn't mix, but I don't know. Maybe it's a new world out there and I'm just not up to date. But this is the kind of stuff that we saw.
So the heat pumps themselves have worked very well. All of our problems came from faulty installation, really. But aside from that, there are a few issues that are related to the project that we are still in need of resolving, and we're working on those. These kind of came out later. We didn't, plan ahead for some of them, and some of them we did know about. But one is we didn't put any heat pumps in the public hallways or in the basement. And, there was some concern that maybe we should do that. We found out the public hallways, no problem at all. We really don't need them. They were fine, and no one even noticed a difference.
Is the building sprinkled?
Sorry?
No.
Do you have sprinkled?
Oh, no, we don't. We don't. But the basement is noticeably colder now, that we don't have the boiler running for heat. So that has been an issue. It's debatable how much of a problem it is. Some people think it's a really big problem. Some people, aren't really bothered by it. But, since the project has been very closely monitored, we know that in the wintertime, the temperature went down into the 50s in the basement. So it was not cold enough to make the pipes freeze or anything like that, which was one concern. That didn't happen. But if you have to spend a lot of time in the basement, it's cold. So we've had complaints like from an apartment on the 5th floor who said, when she does her laundry, she stays in the basement and it gets really cold. Instead of running up and down, 5 flights. We don't have an elevator in my building. So, it means going up and down the stairs, and, instead of that, she was staying in the basement, but it's too cold now. So something we didn't think about. And also, one of the apartments on the first floor is complaining that they're too cold now since the boiler is not producing heat, that their apartment is colder, their floor is really cold, and they've had to turn up the heat pump more, you know, I don't know. So that was another complaint. We have not resolved these yet. We're trying to figure out if there's something we can do to help this.
Can you just add some heat pumps to the basement?
Yeah, we're trying not to do that, really. That is something that could be done, but for one thing, it's how many are we gonna add? It's, the whole floor is the basement, the whole, underneath. And then it's like, do you have them on all the time? Do you just turn them on when you come down? There's a lot of things to figure out if we were gonna do that, and it seems like it would make it a lot more expensive, if we had to do it.
Can you insulate the basement ceiling?
We have looked into that. We have gotten some answers. We have not resolved that yet. That's something we're kind of considering still, because we looked into, should we insulate the ceiling of the basement? Should we insulate from the outside? And it looked to me like the figures didn't make a huge difference with it. It seemed like it would raise the temperature a couple of degrees. So, we have not made a decision on that, but we did look into it. We had
Well, as a first floor dweller, the floor temperature is a different, having a cold floor is different than having air, cold air.
Yes,
It makes a difference.
that's
You can
true.
put a rug.
Well, yeah, let me just.
Yeah, we said.
Let me just say.
We said the same thing.
This particular resident resists the idea of putting down a rug and also has resisted the idea of putting, what is it? Door sweep. They're among the few
And,
apartments that
yeah.
said
Air
they
sealing
did
around
not
the
want
door.
any air sealing
Yeah.
on their doors. So
Yes, that's true.
we've been trying to get them to maybe change their stance on that and see if that solved the problem, but so far they have not.
Smoke cigarettes outside their door.
Yeah, so, Anyway, the other issue we're still trying to figure out is what to do about the hot water. We have not figured that out yet. We're looking into some heat pump water heaters, and we haven't decided yet on that. And they are expensive. Let's see. Some people are again looking into gas, which hopefully we won't. I don't think we're going to go that route, but we're getting prices for it. And there are some issues, like if we have a heat pump hot water heater, if it's inside, we have one bid for a hybrid, and it would be inside the basement, and I'm wondering if that will make the basement even colder, which it probably will. And also, I don't know if there's enough air in the basement for it to be efficient, because the basement is a little stuffy room, so I don't know. So there's some questions we've not resolved yet about that. And, the other thing, well, I think that's basically it. I mean, everyone's noticed that their electric bills are higher, in the winter because of the heating. We expected that. What we do like is, we want each apartment to pay their own electric. When I said, we were thinking of lowering maintenance, that would just be the maintenance. That doesn't mean you're still not going to pay your electric bill. So it still incentivizes each person to be more efficient, because it means their bills will be lower. So we still will have that, and we want that. And the other thing that doesn't help is that Con Ed has been raising the rates ever since we installed. And they are now about to have another rate hike, which is mostly for fossil fuel projects, really. They're expanding pipelines and power plants. They plan to raise the electric by 13.2% and the gas by 19.1%. So gas is going up too. And most of the money goes to fossil fuel projects. The Public Service Commission is probably going to approve it. It looks like it, as they always do. And and it seems like they are not putting any restrictions on how Con Ed is spending our money, which they should, I think. So, we have some issues to deal with here.
Was there anything?
I don't think of anything else.
Yes?
I assume you put the indoor units in the bedrooms and living rooms. Did you put any in the kitchens? And I doubt you put anything in the bathrooms.
We didn't put any in the bathroom. Each apartment decided where they wanted them, kind of with the engineers, that we're helping. So there are some that have them in the kitchen.
Do they have any issues with like filter cleaning or any maintenance issues with having to clean the filter more frequently because of cooking grease and all that stuff?
Yeah, I'm not sure. No one has mentioned it, but it's possible that their filters are getting dirtier.
Are the bathrooms any cooler than they were previously?
They're slightly cooler. We have temperature data on that. They are slightly cooler, but not. People were worried that they were going to be a lot cooler, and they were not. The apartments in this building are very long and thin. And so in some apartments, the kitchen and the dining room and the living room are all sort of part of the same general area. So we didn't deliberately put indoor units in a kitchen so much as just try to spread them out so that they were covered as much of the apartment as evenly as possible.
Yeah, that's mostly true, but Stephanie's is in her kitchen.
I know.
I mean,
Well, 'cause
some of them are, because they're
it's
just
complicated.
configured differently, that's all.
Did anyone want to do the concealed, the slim duct concealed? Everyone did the floor mount or the wall mount?
No, most of the apartments use the wall type,
Right.
and a couple of apartments, well, one apartment, the people complaining about the cold floor, they used all floor mount, and two other apartments used one floor mount.
Yeah,
But
they-
no concealed, ducted.
Ducted?
Ducted, the ducted concealed.
Oh, yeah, no.
None of them
No,
are ducted.
none of that, none of that.
No.
Those are less efficient. So I'm told that.
That's the question.
I know, we're sort of starting to run out of time.
Okay.
I can't speak for Lisa. I could talk here for another 3 hours if you wanted me to. I probably wouldn't. We do have some more slides. I know there's a lot of questions. Should we just stop and go for Q&A? Harris, what do you recommend?
I know there's some things you mentioned earlier that you wanted to get to, so.
Yeah. Okay.
If you want to spend 5 minutes finishing up, then we could do like 5 minutes of ending Q&A.
Okay.
Like that.
All right. Well, let me get to kind of the punchline, which is this is all right. Well, the slides will be available as a PDF if you contact Greenhome, and they'll tell me, and I'll send it out. But I wanted to, this was a strange thing. Okay, so what's the future of residential heat pumps? So, in the course of doing this project, it became very clear to me that there are a lot of elements of it that were less than desirable and increased the cost of the project. And so I came up with the idea of, well, what if we had a heat pump that would fit in a window but not block so much light as a window AC does? So such a product didn't really exist. So my supervisor at NYCHA and I came up with a proposal, and we asked for a request for proposals, and we sent it out, and we got 2 firms that you may have heard the announcement back in July that 2 firms have been selected to build and demonstrate window-based heat pump that was what we call cold climate certified, meaning it's good for the cold weather that we have here in New York. And the first batch of prototypes is going to be delivered to a NYCHA development at the end of June, and we're going to start instrumenting them and seeing how they work and how well they work, what the difference is between the temperature in the living room and the kitchen and things like that. And so in a year or so from now, I'm hoping that we can come back and talk more about those and see how they're working, because I think they're going to be a solution that many buildings will be interested in. So just to give you an idea of what it looks like, basically it's both firms have come up with what I'll call an upside down U type of a system. And this is the same piece of equipment. This is the part that's on the inside, and this is the part that's on the outside. And you can see there's a very thin area that it takes up in the window, so it doesn't block very much of the light. And it plugs into 120 volts. That was a key criterion, because this whole thing with 208 volts, it was a giant pain. It was very expensive to have the electrician and so forth.
Yeah,
So we wanted to get rid of that.
And you don't have all the lines going all over the place.
Yeah, there's, no soffits needed. You don't have to worry about refrigerant line length being too long. You generally will not have to worry about the refrigerant escaping, because it's all brazed connections at the factory. And so why do I care about the refrigerant escaping? So what? Just put in more. Well, the global warming potential of R410A, which is the standard refrigerant in the units that in Lisa's building, has a global warming potential of 2,200, i.e. 2,200 times as much as CO2. They're now starting to use what's called R32, which has a global warming potential of 600 or 700, which is better, but it's still a lot. But if you don't have a lot of what are called flared fittings and all the stuff is taken care of at the factory, the likelihood that you're going to lose refrigerant with a unit like this is very, very low. So this approach has a lot of advantages. And we're hoping that not only will it benefit NYCHA, but it will benefit any building that's interested in the technology.
Can you open the window?
You can open it from the top.
Oh, okay.
So the way this particular one works is it's this upside down U shape, but it's flexible, so they push it out, and then the outdoor piece goes down like that up against the wall. And there's a couple of other options that exist at the moment. This one is in a building in the Bronx, and what they do is the whole unit is inside the apartment, and it takes advantage of the fact that the building has existing P-tack sleeves. And I don't know if you can see, but there's a hole here and a hole here, which lead to ducts in this thing, so that the air comes in and then goes back out through the heat exchanger. But this is only applicable, generally speaking, if you already have P-tack sleeves. If you don't have P-tack sleeves, this is not really quite as applicable.
Are they 110?
Are they what?
110?
Yes. Oh, yes, they are. And then a couple of other things that you can get now. The one on the left is, I believe, a Fujitsu product. It also depends on having P-tack sleeves. And the one on the right also is a P-tack sleeve product. It's made by a company called Ice Air. So there are options out there now. This option is not going to be available for at least the next 14 months. I hope it's as short as that, but we won't know until we've tested them for a full year.